This program is funded in part by Sprint. Sprint, together with Nextel. Stay connected, stay informed. And cooperation with the Corporation for Public Broadcasting and Maryland Public Television.
John Nesbitt, author of Megatrends and a global philosopher among futurists, said it: "We are drowning in information, but starving for knowledge." Here's an example. Theo Walthy of Dow Chemical says Dow has an information pool 22 terabytes deep. To understand that, he adds, just imagine a football field covered with sheets of office paper filled with information. Now stack those papers until each stack is 6.5 feet high, then you have only 1 terabyte of information. Dow alone had more than 17 of these football fields even before it acquired Union Carbide. Now, imagine that those massive amounts of information include top-secret military intelligence and critical images gathered by spy satellites, weather satellites, and planes. Business Now's Len Dybert explores how it's now possible to process these huge amounts of information into near real-time knowledge for the wars on terrorism, natural disasters, and other purposes.
We can do amazing things with the web and with current exploitation tools to take advantage of what we can collect from satellites and airplanes and whatnot. But getting it to the people who need it and getting it in a timely fashion, getting it with the accurate information they need on that image is still, still a huge growth area.
General Dale Waters is the former military executive and director of military support and operations for the National Geospatial Intelligence Agency.
If you can take surveillance video, overhead video, geospatial information, accurately turn it into a product and display it, and then transmit it to the person who needs it on the ground or in their location, that's what will make a difference in terms of saving lives and getting the mission done.
That's the goal of Sterling, Virginia-based Pixia Corporation. It has developed leading-edge software to store and quickly retrieve massive amounts of data.
For us, massive is not, let's say, the equivalent of one set of yellow pages, but let's say millions and millions of books of yellow pages, and being able to identify or pick one person out of that in, say, a tenth or a hundredth of a second. We've heard a number of very high-ranking U.S. officials say that their problem is not having massive amounts of data, it's extracting useful information from the massive amounts of data is the critical thing. And we do think we fit into that perfectly.
We have a solution, a software solution for accessing that data very quickly, storing it efficiently, managing it so that it can be disseminated very quickly, be that to somebody in a local conference room or control center or to boots on the ground somewhere out in the field.
Here's one example of the Pixia technology. This is an image of Prince George's County, Maryland.
Being able to now seamlessly go into any location, so let me zoom in all the way into this image and be able to manipulate and move through that image at this speed is something that before was just unthinkable. So let me again just zoom out and go into, let's say, Andrews Air Force Base. There's Andrews Air Force Base, and I can instantly start roaming around and looking at the area. So again, this actually equates to literally almost a terabyte of information, originally as 7,500 individual files, and we've just made one simple file out of it that I can instantly access and navigate.
Here's an example of how Pixia's technology can be used in video streaming for surveillance or reconnaissance with a fixed camera.
So this has obvious applications for the military, especially when now one of the hottest topics being IEDs, or improvised explosive devices, of determining who approached the site, when did the IED go off, and then who left and where did they go, to be able to capture them. We could, with limited amounts of sensors, essentially stop anyone from crossing the border, at least above surface. You would instantly be able to see where they are, what they're doing, and it would require minimal manpower. So by just having a few sensors up in the sky and having a few computer systems in one room, you could basically essentially lock off the entire border.
Pixia says the company's performance, scalability, and speed are based on its proprietary patented NOO-ee software.
Before Pixia was able to add this capability of having this kind of a file format and file structure, Every time that I moved on a conventional system, I would wait for literally tens of seconds, if not minutes, for the image to pop up. So our value add in this case is just the ability to instantly roam through the imagery and access it, was something that was previously just not, you just weren't able to do it.
Patrick Ernst has an entrepreneurial background. His brother Rudy is a veteran of the entertainment world. He worked in research and development for Disney. When Pixia was founded in 1999, Rudy assembled a team of highly sophisticated software engineers, people like Raul Thakkar, who earned credits for his visual effects on DreamWorks' Shrek and Ants. Thakkar says Hollywood sparks the imagination and breaks all boundaries.
Each individual in the company looks at our products from a customer's point of view. So no matter how cool it is, no matter how amazing the user interface is, no matter how amazing the technology is, if the customer is not happy, who cares? On the side of the Department of Defense, a warfighter or a person using the technology really doesn't care about how cool it is. They want to use it. You are constantly striving to save lives. I mean, you mess up, somebody's going to get hurt. We can't afford to do that.
With their Hollywood backgrounds, no one knows better than Raul and Rudy Ernst how movies and television have overhyped and misled the public about the capabilities of geospatial imaging. General Waters is very clear.
The accuracies are classified, but I think most of what you see on movies and TV about ability to identify faces and numbers on license plates is beyond the capabilities of most systems.
Rudy Ernst does not focus on the limitations of connectivity and bandwidth, but on what can be done.
What we will guarantee is no matter how much, or in most cases how little bandwidth you have, we'll guarantee that we'll squeeze out every bit that we can per second out of that pipe to make sure you get the highest performance possible.
Pixia put those words into action when Hurricane Katrina battered New Orleans. Pixia worked with NOAA, FEMA, and global engineering giant URS Corporation to assist in disaster response and recovery over a 13,000 square mile area.
We literally, within a day, were able to acquire imagery from NOAA and then disseminate those to the end users out in the field. You can clearly see that there was a breach that occurred here. And if I head due east of this levee breach, you can see how all the properties are completely submersed in water.
Whether you're talking about the warfighter or an emergency responder, there's a tremendous amount of value for people to have actual image data.
URS Corporation sent hundreds of people to the hurricane-ravaged area. First responders and recovery workers with laptops and PDAs used the aerial images from Pixia, transmitted to them over the internet. Karen Schuckman is Geospatial Technology Leader for URS Corporation.
There are just a lot of uses. Having a picture of the area provides a certain situational awareness that is really difficult to get in any other way. Pixia has made a unique leap across that gap between special effects and visualization and video streaming into a real supporting it, a real robust information, geographic information solution.
Hearing for the first time when it was used and that there were actually folks, pilots and helicopters, that were using this as they were doing their rescue missions and using our technology to get a better sense of what the ground looked like before they flew in there, that was a tremendous feeling of success.
The Pixia team believes its solutions have numerous applications beyond natural disasters, homeland security, and imagery for the Army, Navy, and the intelligence community. Its high-resolution images can be used by local and state governments, in medicine, and gaming simulation. In biometrics, Pixia's technology enables millions of fingerprints to be stored in a single file and recalled virtually instantly.
It doesn't just apply to satellite and aerial images, but any kinds of records that you have, as long as the number of records becomes basically unmanageable because it's so many individual records. Our value proposition, very simply, is that Pixia will be able to read and write whatever file format you would like faster and more efficiently than anyone else.
Rudy Ernst and the Pixia team base this confidence on the belief that no one on the globe is focusing on this single problem exclusively like Pixia. I'm Len Dybert, Business Now.